Hi there. I'd just like to show you a real-time graphics programming technique now, and it's for real-time nebula effects like this one. You might use these in space games. It's not entirely realistic, but as you'll know if you've played games like Star Trek Online or EVE Online, sometimes graphical effects need to take a back seat to other issues such as gameplay and network traffic and so on. So this technique is useful because you can view it from any angle. You can generate these at real time, and it doesn't rely on particle effects or billboards or anything like that. It's some simple static geometry, and as you can see here, we can generate new ones on the fly. So how does this work? How do we create this nice smooth effect? Well, you start out with a single polygon. I'm sorry if the video quality isn't very good, but hopefully you can see it. If we introduce a polygon to this scene, that's the white outline there. What we do is we apply a texture to that polygon and we blend it additively. So there we go, just a simple cloud kind of coloured texture. And the idea is that you layer up multiple of these at different orientations. There's the wireframe, you can see all these different polygons there. And as we move around it, you can see we're almost getting the nebula effect. The problem is you can still see the edges. That's because it's just obvious that there are flat surfaces in there, and those obviously create artifacts. It's not ideal. We want to smooth it out, so it looks perhaps a bit more like this. So how do we get to that from the other one where you can see all the edges? Well, the principle is reasonably straightforward from a mathematical point of view. It requires you to do a bit of calculation on a per polygon basis. Here's the wireframe. You can see different polygons are fading in and out at different times. The ordinary wireframe looks like this. You can see all the polygons all the time, but with the fading, you can see not all of them are visible. Now, it's maybe not clear there, but if we reduce this all the way back down to one polygon, I can show you what's actually going on. So normally the polygon's visible at all times, completely visible. But if we turn on this fading technique, you'll see that it fades out as the camera approaches an edge-on view. If we're viewing it straight on, then it's at full opacity. If we're viewing it side-on, it's at full transparency. And you smoothly interpolate between them. And if you have enough interlocking polygons, then it should be possible to view this nebula effect from any angle and get this sort of three-dimensional impression. So here's multiple polygons all layered up. And this is again what the wireframe looks like. So this is generated at real time because you can just tell it to create a whole bunch of polygons at whatever orientation it feels like, random orientations, slightly randomized positions, and even randomized textures. So what is the mathematics behind actually calculating this? Well, we start with a polygon, that's the black line, and the normal of the polygon. That's the red line, the red arrow, which we'll call V1. That's a vector. We also know where the camera is located relative to the polygon, and we'll call that vector from the polygon to the camera V2. We want to find out the angle between these. That angle is A. And what we can do is use the dot product, V1 dot V2 equals the cosine of that angle. The cosine is a very useful value, and in this case it's very efficient to calculate. As the camera approaches a straight-on view like this, the cosine of that angle tends towards 1. As it approaches a side-on view, or even just a side-on position, the cosine of the angle tends towards 0. And as it goes directly behind the polygon, the cosine of the angle tends towards -1. Now if we take the absolute of that cosine, we end up with a value between 0 and 1. The closer to 1 it is, the more straight on the view. The closer to 0 it is, the more side on the view. So you just use that as your alpha value for rendering the polygon. And that's what allows you to fade out an individual polygon based on where the camera is. And you apply this to each polygon to build up the effect. Now what about the textures? Now I'm not much of an artist, but I just created a few of these textures by using a plasma generation filter in the GIMP in this case, then applying a couple of layer masks. So you can see these are quite colourful plasma effects. Now we use a basic cloud generation effect using black and white, but we turn the white into an alpha channel. and what that allows us to do is mask the colors. And finally we use a circle mask, and the reason we use a circle mask on top of that is so that nothing goes in towards the corners and nothing goes towards the edges. There's the circle mask. And it's very important not to get anything towards the corners or edges, because that will give the impression of basically a rectangle, and it will totally defeat the purpose. So here are all the layers put together to create the kind of nebula cloud effect. And the nice thing is you can swap out different cloud masks, you can swap out different colourful plasma layers to create lots of different effects. For the nebulas I've been showing you, I've only actually used 3 different textures. You can use several textures if you want, but try to make sure the colour schemes are at least moderately compatible, otherwise your nebula is going to look a little bit odd. So finally, just going back to this demo, you can see several interlocking polygons, apply the textures, additively blend them, and that's quite important. Make sure you're additively blending them and not doing any depth testing, and you'll be able to build them up like this. And you can randomly generate them, as I've said before, and this can be very useful, particularly if you're creating an expansive universe. And remember that what we're trying to avoid is creating that kind of feel of edges. What we want to create is this nice smooth effect, getting away from the edginess, getting away from the flat polygons. So I hope you find this useful, and it can be done using OpenGL or DirectX. If you have any questions, please feel free to leave a comment, and I'll see if I can answer them. Thanks for watching.